Good morning, students. In the last session, we saw some representation of relation. So we have already studied about relations and the various representations of relations. Now moving on to a higher level of relation, let's see what a function is. Okay. So according to the definition that I have written on the slide, a relation defined by A is a function if for every element of A there is an unique element in B. So according to this definition, you must be very clear that a function is nothing but a relation. What did we see about a relation? A relation is a set of ordered pairs. Likewise, a function, since it is a special relation, it is also a set of ordered pairs. Now, before going into the mathematical definition of a function, let me explain what a function is in the layman's definition. A function can be viewed as a machine. So, for a machine to function, for a machine to work, there must be some input given. And based on that input, the machine will respond. So you have an output from the machine. So what do you understand? As the input varies to the machine, so will the output vary from the machine. So you see that the output of the machine is dependent on the input to the machine. Okay? So you should be very clear that a function is nothing but a machine. So it accepts some inputs and produces some outputs. And the inputs are variables. Likewise, the outputs are also variables. But there is some relationship between, some correspondence between the input given and the output that is being achieved by from the machine. So, shall we represent a function mathematically? How is it denoted in maths? We use all the small letters, namely F, G, H, okay, to denote a function. Mostly it is written in italics. So wherever you find small alphabets written in italics, you can say identify it as a function or something like this. Y is equal to f of x. If it is written like this, then once again you call that also as a function. Okay, let me give you some examples of a function in real-time world. Let's consider the rotation of a fan. The rotation of a fan is dependent upon the voltage supplied to it. So, if there is fluctuation in the voltage supply, then automatically you can find that the rotation or the speed of the fan varies. This is a function. Another example. Say the shadow of a particular person is dependent upon the height of the person. So as the height of the person varies, likewise the shadow, length of the shadow will also vary. This is also a function. Another example, as I told you prior, the femur bone is connected with the height of a lady. So I told you what a femur bone is. It is nothing but the bone that is present between the hip as well as the knee, the connecting bone. So the length of the femur bone determines the height of that particular, say, lady. One more example, let's take up like this. Let's take up the automobile industry. To be very specific, let me take about, say, BMW, Then you have say a Benz, Toyota, and say Suzuki. All these companies, these are various companies. These companies produce various products, various car models. So when I am going to show a relation between the company as well as with its models, then that is also a function. So I hope I have given you some, say, real-time examples of what a function is. Now I will show it mathematically. So how is it represented mathematically? As I told you, a function f is a mapping from a set A to set B. This set A is called the domain. Set B is called the codomain. So according to the definition of a function, every element of the domain must have a unique image in the codomain. A unique image in the codomain. Thus you understand that there cannot be any element left without an image in the codomain. Students, in this session we are going to see some examples of a set, a function, and the various terminologies that are involved in this particular concept, function. Okay, to introduce with, I'm going to introduce to you about a domain. So what is a domain? A domain is nothing but a set. This domain of a function f, which has a mapping from the set A to B, is a set of all elements of set A. So let's just look at this example. I have a set A of elements 2, 3 and 5 and set B of elements 4, 9 and 25. Now I'm going to define a function, a mapping from A to B, and that is defined by this A divides B, which means that the elements in set A are going to divide the elements that are present in set B. Okay, I am mathematically representing it by means of f, such that A is a mapping, A is a function, A is mapped to B. Now what are the elements of the domain? A domain is a set. So I told you, since it is a set, you will have to write it like this. Now what are the elements within this? The elements of set A are the elements of set of the domain set. So 2, 3 and 5 are the elements of the domain set. So what do you understand? The elements that are present in the domain is equal to the elements that are present in set A. So can I write like this? So domain of a function, that is d suffix f, is equal to the set A, from where the mapping starts. Now what is a codomain? A codomain of a function f, which has a mapping from the set A to B, is a set of elements of set B. So codomain is represented like this, C suffix f. So let me list the elements of the codomain. So CF is a set which consists of all the elements of set B, which is nothing but 4, 9 and 25. So this is the codomain. Moving on to the definition of a range. What is a range now? A range of a function can be defined like this. A range of a function f, A to B, is a set of elements in the codomain B that have a pre-image in set A. So a range is represented like this, R suffix f. So consider those elements that are present in set B. What are the elements that have a pre-image in set A? 4 as a pre-image 2, 9 as a pre-image 3, 25 as a pre-image 5. So these elements are called the range. So how can I write it? So range of the function f, of this function f, is equal to, it is a set. What are the elements? It is nothing but 4, 9 and 25. Okay, just look at this answer that you got. 4, 9 and 5. So range is equal to set B. Let me just include one more, say, element inside the B set, and I will show you the difference and then I will complete the definition. Let's consider that I have an element, say 31 here. I have changed the set elements of set B. So 31 is being included in set B. Does 31 have a pre-image in set A based on this function, namely A divides B? No. No element can divide 31. Therefore, we see that 31 will not be present in the range. When 31 is not present in the range, what can you define a range now? Range can be defined as a subset of the set B or the codomain B. So how can we write it? So RF, okay, is a superset of the codomain of the function f. As I told you, in this example, RF is a subset of the codomain f. Sometimes the range can be equal to the codomain also. When will it be equal? When the set does not have 31, then my, say, range will be equal to the codomain. Okay, children, we will be able to understand this function if we represent it by means of an arrow diagram. I will show this same function by means of an arrow diagram. Say, and we'll check whether it is a function or not. So, in an arrow diagram, you will be representing the sets like this. So name this oval as A, this as B, and write all the elements within A like this. Okay, B as elements 4, 9, 25 and 31. Now we are going to map the elements of the domain with the codomain. Okay, under what mapping? The mapping name is F here, or we can write it like this: divides. Okay, this is the formula, divides. So 2 divides 4, 3 divides 9, 5 divides 25. So what are the elements of the domain? The elements within the domain are 2, 3 and 5. What are the elements of the codomain? 4, 9, 25, 31 of the elements of the codomain. What are the elements of the range? 4, 9 and 25 are the elements of the range. So this is how we show it in the arrow diagram. Okay. Moving on to the other representations of a function. Now, before moving on to the other representations of a function, just look at this arrow diagram. See that it satisfies the definition of a function. What is a function? According to a function definition, every element of set A, from where the mapping starts, every element of set A must have a unique element in set B. Must have a unique element in set B. Apart from the arrow diagram representation, we have other representations also. So, how will you represent the same function? By means of a roster form. Say, I already told you that a function is a relation. So, a relation is a set of ordered pairs. So, while you are writing it in roster form, you will have to write it in ordered pairs. 2 is mapped with whom? It is mapped with 4, and therefore that is written as an ordered pair. 3 is mapped with 9, therefore that is also written as an ordered pair. Likewise, 5 is mapped with 25, and that is also written as an ordered pair. It is mapped with, based on this function, namely divides. Okay, so now we find that f is a subset of a relation. And then in the set builder form, you see that x comma y such that x comma y, the elements within the function are ordered pairs. So it is written as x comma y such that x is an element of A. X comes from the set A, and then x comes from set A. Y is an element of B. Y comes from set B. Y comes from set B. Okay? And I am writing the formula also. Based on what did I get this answer? I got this answer based on this, say, formula. X divides Y. X divides Y. X divides Y. X divides Y. So students, now that you understand that a function is nothing but a subset of a relation. And we have already studied about the relation. A relation is a subset of the Cartesian product. So this diagrammatic representation depicts it very clearly for you. Moving on, I will show you some examples of what a relation is not. Okay? Let's consider this problem here. Say A consists of the elements 2, 3 and 5. B consists of the elements 4, 6, 9, 10 and 15. And I want to show a relation based on this. A divides B. Okay? Now, we will first show it by means of an arrow diagram. You'll be able to understand it more clearly. So, the elements of set A like this and name it as A, and the elements of set B like this and name it as B. Now I am going to show a mapping between. Okay, let's see whether this is a function or not. Okay, so we are considering the same formula, A divides B. So according to this mapping, we see that every element of set A has got many images in set B. It does not have a unique element in set B. According to the function definition, every element of the domain should have a unique element in set B. But this diagrammatic representation shows that it does not satisfy a function, and therefore this is not a function. But this can be a relation. So we see that a function is a subset of a relation. This is not a function. So in the next class, we will see something about the types of a function.